Hello everyone, my name is Willow Newman, and today I'm going to be talking about the thermal tolerances of fishes in the Kings River, Arkansas. I would like to thank my co-authors Chance Garrett, Matthew Gifford, Jenny Adams, and Reed Adams for their contributions to this project. As we all know, global climates are changing. Shown here on the y-axis in degrees Celsius is global average surface temperature change, and on the x-axis we have time in years. There are two options shown, one in which there is action taken against climate change and one in which there is no action taken. If we are to expect increasing temperatures, we can also expect water temperatures to increase. Normally, perennial streams are likely to become disconnected or dry up, and streams may become dry for longer periods than in the past. This yearly cycle naturally occurs in the White River watershed. However, the cycle is becoming more pronounced. The Kings River is a beautiful river that flows through the Ozark Mountains of northwest Arkansas. It even contains some species that are endemic only to the Ozarks. Despite its recreational popularity, the Kings River has not been studied very in depth. The goals of this study were to expand baseline data on thermal tolerances in the Ozarks. In 1995, another study was done by Smale and Rubini that covered 8 of the same species that we cover, but we wanted to expand that data. We also wanted to establish a community-level critical thermal maxima data set on the Kings River. And finally, we wanted to identify the species in the Kings River that are most vulnerable to temperature increases as climate changes. We collected fish using seines, and when the fish weren't in the river, we held them in aerated, temperature-controlled buckets. We used river water in all of our experiments to remove the confounding variables of water chemistry. After collection, we held fish in flow-through baskets for less than 24 hours, usually overnight. In this experiment, we did not perform any lab acclimation, which is the usual standard for critical thermal maxima datasets. To replace lab acclimation, we measured the river temperatures during the time of our experiments. This simulates the natural conditions that fish were experiencing in the river, which allows us to capture a 6-degree temperature difference over a 24-hour cycle, which would be very hard to replicate in a lab. Shown here is us setting up our lab, hauling water, and looking at fish in their aerated buckets. For every trial, we used 4 fish, and there was constant flow held in the temperature bath. Temperature was increased at about 1 degree Celsius per minute to determine a fish's critical thermal maxima. A critical thermal maxima is the highest temperature a fish can withstand before it is susceptible to predation or other factors in the water. For our purposes, loss of equilibrium was considered to be CTM, and that is when a fish turned upside down and could no longer right itself. Once a fish was observed to display loss of equilibrium, the temperature was recorded and the fish was removed from the bath. It was placed in a corresponding cup, shown here, to allow the fish to recover from the temperature. This was very successful, but notably Natropus percobromus and Natropus telescopus, 2 fish species that we studied, were observed to recover on fewer occasions than other fish. After each trial, fish were weighed, measured, and identified. They were returned to the river, and this notably had a high survival rate. Overall, we tested 23 species, 229 individuals covering 6 families. We noticed that there was variation among families. The ones that were not different from each other were Catostomidae, Cyprinidae, and Percidae, and this can be explained by ecological differences noted between these species. Whether or not a species is endemic was also considered in our analyses. Endemic means that these species only live in the Ozark Mountains. If the fish were an Ozark endemic, they had a significantly lower tolerance than those fish that were not endemic. Shown here on the y-axis is mean critical thermal maxima, and on the x-axis is species name. These are organized from lowest to highest critical thermal maxima. The red line shows the highest temperature we observed during our study at the Kings River, and as you can see, all species CTM are well above this temperature. So overall, the fish with the lowest critical thermal maxima were codded fish, run fishes, and fish that were endemic to the Ozarks. Our unique methodology allowed us to capture a temperature increase and decrease over time, and we think that as compared to Smale and Rubini, we were successful in describing the critical thermal maxima of these Ozark fishes. I would like to acknowledge the following organizations for their contributions to my project. If you have any questions, please email me, and thank you for your time.